Hi guys, this is just going to be a quick video walking you through how to do the calculations for the ideal gas law. So this problem is number 1 right here, and it will be on your ideal gas law worksheet that you can find in Schoology, or that we'll be doing in class sometime this week. So this will be a great video if you need to look back on how to do these calculations, or it'll be a good reminder on what to do. So I'll try to make it quick. So the ideal gas law, remember, is the equation PV equals nRT. So the first step in solving these equations is to find all of your variables. So we'll start right away with P, which in this case it says calculate the pressure, so we don't know what P is. Next we have V, which would be our volume. Should be 2.5 liters. Then we have N, which is the amount, so that would be our moles. So 1.35 moles. And R is going to be that constant that was given. So the constant is 0.0821 liters times atmosphere over mole of Kelvin. So it's pretty messy, just ever so slightly, but we'll work through it in this problem. And then our temperature is given as 320 kelvins. So there's no extra calculating that needs to go into this since you already have your temperature in kelvins. So now, since we have all of our variables outlined, we can start plugging it into the equation. So we don't know what P is, so that'll just stay as its letter. But we know the volume is 2.5 liters, and that equals, we have 1.35 moles times the constant, 0.0821 liter atmosphere per mole Kelvin, and times 320 kelvins. So now you can kind of see how this problem is set up, and at this point you could solve it. It'd be just your simple algebra, so you could divide that number by 2.5 liters, and that would get rid of the 2.5 on that side, leaving you with just the P. So you are very easily able to solve it at this point, but remember, we want to, that was way bigger than I thought it was going to be. We want to know where the units go. We want to make sure we cancel out so we get the right units. So the unit of pressure in this is atmosphere. So this is what we want left over. So if we put it back into that table, very similar to the unit conversions that we did, you are able to visualize where those units go better. So we know that all of these numbers on the right will be on the top of the equation just because they would get divided by this. Ooh, you can't even see the 2.5 anymore. 2.5 liters. So we'll just start plugging these in to our table. And you have your constant, 1. Oops. I gotta change that up just a little bit. Over, so since there is a fraction in this unit, you can put the mole Kelvin at the bottom. Then we have 320 kelvins, and we know that it'll all be divided by the 2.5, so you can just plug that into the bottom somewhere. So now you can see where all of your units are. So since there's a mole on the top and a mole on the bottom, you can eliminate those. There is a liter on the bottom, liters on the top. There's a Kelvin on the bottom, Kelvin on the top, which leaves you with just atmospheres. So that is what I mean by doing a unit check. You want to know where they all disappear to and how it all works itself out. So at the end of all of this, if you want to get the number right away up here, just divide 1.35 times 0.0821 times 320 divided by 2.5, you will get the answer. Let's see, I'm going to calculate this quick. Pressure equals 14.2 atmospheres.